Good afternoon, everyone. I'm usually used to like standing in front of the slides and looking at the slides and try to point at them. But I'll try my best, still not looking too much to the side. I'll try to concentrate here. So what I'm planning to do, okay, a little bit of introduction about me. I'm the head of R&D for controller applications and AI at Nokia. I have been doing AI for quite some time. And there are lots of experiences. I wouldn't say all good, but all leading to good outcomes. That's what I should say. Okay, so what are we going to talk about today? The focus of my presentation, I know that we mentioned automation and AI, but what I'm going to be talking about is to take automation to the next level. That's why I call it AI-powered networks, from automation towards autonomy, right? That's essentially what the crux of my presentation is going to be. Automation is already old, right? Just a state-setter slide here. If you look at how our industry has been transitioning over the last few decades, everybody knows the famous internet era, right? Where the Googles and all the, what we call hyperscalers right now used to just be like Yahoos and Googles. So at that time, it was all about providing internet service. It was primarily data. Later on, it became dual play, and then it became triple play, cut the cord, and all that. All that revolution took place around this first set that you see here. At that time, the focus was primarily on making sure that when a subscriber calls and asks for a service, try to get that service delivered to him or her. And in order to do that, they had people sitting in front of machines that had nice GUIs, and they were able to click and get things done with a couple of clicks at most, right? And there were lots of advancements like, okay, I want to do this with a single click, I want to have more abstraction and all that stuff. All that was done in those ages too, but it was primarily focused on GUIs and manning those GUIs. But then came the scalability aspects. The network started to grow rapidly. Everybody started to move towards using internet more as a need and necessity, and there were more and more services, more and more networks that needed to be brought into this whole paradigm of management. And it was becoming very difficult for the service providers to handle this scale and complexity. And so they started looking at, okay, how can I now make this simple so that I don't have to employ 100 people that are manning this each and every time when there's for example, a new service request that's coming in. And that's where the term automation came in, virtualization, and you probably all know about software-defined networks. We were in that software-defined networks era for some time. The last 10 years, actually, there were lots of advancements also in Broadband Forum. We were doing quite some work there, standardization and all that, primarily focused on programmability. How do we make our networks programmable? How do we make how do we move out from management towards what we call controllers so that we could make automation happen? So that was already a game changer for the service providers. What they were doing with 100 people brought it down to much more efficient operations, right? It was like time to market. It helped in improving customer experience. It rapidly helped them in delivering these services to the market. And their open APIs, the term open API became very, very important, because if you have to interoperate with third-party BSS and OSS systems, your vendors, controllers have to be interoperable with them, and they have to provide what's called an API that is open and usable by all those higher layers. And that's what we call the SDN era, or sometimes the controller eras. We moved from management towards more controlling the network, programming the network, and automation. Now we have arrived at what I call the era of autonomous networking. And what I mean by that is it's not just about massive automation. It's also to look at that low-risk items and activities that happen in the network and let the machine take care of it on its own. Again, I will come back to it. Don't think that the machine is going to do everything magically or automagically, but that's where the key is. And that's essentially what I call the AI era. You can call it anywhere, anything, but it's the autonomous era. AI is going to be essential, very much crucial to get there. And there are other technologies too, like digital twins, intent-driven or intent-based, and AI agents, which I will talk in the next few slides. Okay, just to give you, I'm not going to go into the details of every level here. This is actually a slide from TM Forum IG 1251. This is talking about the different levels of automation that you can see in a service provider network. This is, by the way, it's not like these levels are mutually exclusive, right? It's stepwise. You go from one level to another. It starts all the way, it's before, like I showed in the previous slide, from several decades ago where there were manual operations and maintenance, to assisted operations and maintenance with a little bit of automation, to partial autonomous operations with high-end scripts and high-end netconf and yang and resconf-based automation. And then conditional automation loops, where you can also let the machine to automatically use policies, workflows, and all that to close the loop where it can. And now we are moving towards what's called the layer 4 and the level 4 and the level 5 autonomous networks, which is considered the highly autonomous networks. By the way, when I say autonomous networks, don't think that everything in the network has to be autonomous. It is not necessary for every operation in the network to be autonomous. You have to look at where you get the best return on your investment. What makes sense to automate? What makes sense to make autonomous? What is possible to make autonomous? That's going to be the key when you start investing. And that's also what this whole standardization is looking at in terms of use cases. There's a bunch of groups that are working on it. TM Forum, Broadband Forum at C, 3GPP, IETF, and it's going to be a collaborative effort across all these organizations because openness is going to be key, and I'll touch upon that as well later when you're working with all these different kinds of technologies. The three highlight technologies that I want to talk about here for moving towards autonomous networks, especially to level 4 and 5. A, intent-based networking, which is taking the high-level goal and translating it to the details without knowing to have the higher layers deal with it. AI ops, which is AI-driven operations. How do you use AI in your operations where it is necessary and needed? And agentic AI. Agentic AI is, just think of glorified AI ops. You can have all sorts of AI operations, and now you want to automate even those operations on top and orchestrate them on top, then you'll use what's called the agentic AI. I'm not going to fancy you with all these terms. I'm going to talk a little bit about it in my slot, but you're going to hear these terms again and again when my fellow speakers are going to talk as well. Okay, now a little bit to the basics. Everybody knows about sense, think, and act from the robotics industry. Networks also very much relate to that paradigm. Anything that we get from anything that the network has to be looked at to know if you need to automate, if you need to bring something to autonomous operations. And what you see in the bottom here is the network. And how do you keep in touch with the network's reality at all time is the fundamental thing that you have to look at here. If you don't have the real attributes that the network has at all times, you're not going to be able to know or even automate any of your operations. That's essentially where the telemetry comes into play. The telemetry, there are several mechanisms, and if you want massive telemetry information, you may need to go towards advanced telemetry mechanisms like streaming. So once you get these telemetry data, which could be either alarms, metrics, it could be inventory, it could be logs, anything that's available at the network that it knows in real time. All that can be made available to the controller, which can then be analyzed by the controller. That's the sense part of it. That data is analyzed by the controller, and you can also think. That's where the controller is going to start making decisions based on it. Like first it's going to infer what's going on, like just by looking at the data, putting the red dots together, putting the green dots together, the blue dots together. That's a very simple example. It can first start creating insights out of it. It can detect anomalies and lots of other things that come out of it. So that's the first and the foremost part. Sensing the data, learning the data, and providing what it knows about the data. The next part that you see the line here, which is the act. The act is essentially where the autonomous operations comes into play. The autonomous operations, you can basically go change some configurations, change some QoS parameters, for example, for optimization. You can do a policy or a workflow to optimize certain things in your network if you see that it's not going as per expected. You can also automatically do trouble ticket resolutions, and this is all what we call closed loop automation or optimization. Okay, this all looks good, right? I very simply said you can autonomously act on these things after you have inferred the insights. But is there something missing here? Do we see that something doesn't gel very well? I mean, how is it that the machine is going to just automatically think and act on it? Is it all that simple? Isn't network data going to tell you everything on how to act on the network? No, not really. That's where the humans come into play. And in the previous slide, when I talked about the NMS and the automation era, the humans were actually a part of the operations loop. They were trying to be a part of inside the operations loop, trying to make these decisions and act on it directly. Right now, with the AI era, what we are trying to do is take the humans from deep inside the loop to outside on an outer loop, where they also get all these insights, and they can use these insights to train the machine, to inject actions into it, which the machine can further learn to act on it. And that's essentially how the machine knows how to act on it. It doesn't magically know how to act on it. Of course, there may be some optimization-related things that you can do, but there are very few use cases like that. If you really want the machine to act on something autonomously, at some point in time, there is a human involved. But it does not mean that the human is always involved in the operation cycle. Another thing to look at here is that it's not always just the actions from the operator. Sometimes it's also external field data. Like, for example, if a technician is going to a field and collecting some data from passive equipment or even the ONTs, that can also be fed into the system, which can be used to learn as well. So there are lots of ways that the machine can learn to infer these autonomous operations. Now, it's easy to say that, yeah, once you have all these operations, you can automatically try to act on it, but do you really want to act on your live network and without knowing for sure that it'll be okay? And that's where the what-if scenarios with the digital twin comes into play. It's very important to make sure that when you're trying to roll out something to your real network, it's 100% accurate, and trying it and validating it on a digital twin is going to be very key. Digital twins are going to be exact replicas of certain functions that you want to validate. That is a copy in the virtual cloud or anywhere for that matter, which will validate whether your actions that you're trying to do from the think part of your loop here is okay or not. And once it's okay and once it says, fine, it's okay, good to go, and it's marked as labeled, those actions can be a part of your loop autonomously. And that's how typical autonomous networks are realized. It does take a lot of process to get there. It's not like, everybody says, throw AI in there and everything gets there. It's not as simple as that. Okay, now let's look at some use cases, just to make it a bit more concrete. In fiber networks, what are some of the use cases that we have productized and brought it to operators? The very easy thing is to, of course, like I said, if you're able to analyze patterns, you can say if something is an outlier, you can detect that, and you can flag it to the humans, and the humans can make decisions based on it, and then, like I said, you can also do autonomous operations on it. Another thing that you can do is neighbor analysis without having to do this on every time series, without having to do it on every metric. If you know that there are several ONTs of the same kind, you don't necessarily have to set thresholds on each and every one of them. You can let the machine automatically group them because they know that from inventory. You don't necessarily have to tell the machine what it is. It gets all the data from the inventory and learns it, and then knows, okay, these things have to have similar characteristics, but why is one deviating from the other without having to specify, do this particular policy or workflow on that. The other thing that we can do, we have traffic utilization. We can actually enhance this with digital twins for capacity planning to not just look at the average utilization, also look at the utilization during peak hours and also speed test success probability during peak hour. So that's something that you can very easily do if you've modeled it. And bandwidth management, everybody knows that PON especially during peak hour. And I think Craig was talking about his son gaming and he working from home. Just imagine if it's not his son, if it's his neighbor's son. How do you take care of that, right? That's fairness across users of the PON. And there it's something that we can actually look at heavy users and make sure that we give fairness to the users that are using the PON like they're supposed to, still honoring the SLA. Using the same kind of mechanisms, you can also profile the subscribers and look for potential upsells because, yeah, service providers are looking for ways to monetize the network as well. And the last but not least, it's always about making your operations nimble. Assistance to humans, because if you don't provide assistance to humans, you'll never be able to get to autonomous networks. And there could be lots of different types, be it for troubleshooting, be it for NOC, using generative AI, or whatever kinds of techniques it is, and also for field installation. Digitizing the field installation is going to be key as well because there are a lot of problems that customers face today. So let's look at how AI as such can improve the operations aspect, because I know that a lot of service providers are looking at the operations side of it. One, make sure that your build and connect is digitized. You're not doing a lot of manual operations. Make sure that the inventory is always up to date. AI can do this. Fault handling, predictive care, and like I said, capacity planning as well. And the same with NOC, like I said, with generative AI, do the same thing. Use RAG, use SQL agents or domain controller agents to make sure that you can provide all this information back to NOC agents, because generative AI is one area where it could be used for NOC. There's going to be a user there, and slowly you can build it to make it totally autonomous. And last but not the least, one thing I want to finish my presentation with is, like I mentioned before, if you want to do all this, and if service providers want to do all this, they cannot do it on their own. They have to rely on vendors, and vendors also cannot do it all on their own. They have to rely on different players in this space, be it AI companies, be it hyperscalers. Its openness is going to be key. And also multi-vendor interoperability is also going to be very key. Thank you.
Thank you, Sireesha. This conversation will continue because there's a lot of great food for thought there.